work on, because I still saw in your homework something that I don't want to see. I mentioned that if you want to solve this equation, yes, you can write this, and then you can write this, and then you can write this. But if you want to solve x squared minus 9 greater than or equal to 0, if you write this and you take square roots, I can only give 0 points, because that is not allowed, and I said it very clearly last time or last week. Never. This is not allowed. It is allowed in an equation, but not allowed in an inequality. So please do not do this. Okay? What you have to do, and yes, I think I saw a different method. Awesome, awesome method, acceptable. But you have to show that you factor. I don't remember who it was. I saw someone who said this is -3, this is +3, and said positive, negative, positive. I accept that method. That's fine. But I don't accept this because it's incorrect. Okay? So because we are looking for positive, yes, I saw the domain was -infinity to -3 with a bracket, parenthesis, of course, at infinities, union 3 to infinity. That's fine too. But you have to show something. What I like to show is that little table, which I think is very simple, but you may say, nope, I don't like it. That's fine. This is fine too, in which I present, as we discussed last time, -3 and 3, 0 here, 0 here. They're both linear functions with a positive slope. So they go from negative, or come from negative, go to positive. You can plug in numbers, 0, 0, positive, negative, positive. Fine. Both methods are acceptable, but not this one. Good. So did we find that that question, Sloan?
Yeah, I put it in the chat.
Okay, let me go back to the book because I have the book ready here. Okay, can you tell me the page? Oh,
it was in my math lab.
Oh, gee, yeah. So let me see it in the chat. Is it? Do we have it? Do you have a picture of it, or oh?
Yeah, I can just tell you if you want me to.
Yes, yes. Let me copy it. That's perfect.
Okay.
I'm ready.
It was to find the derivative of y equals 7x to the -3/2 plus 4x to the -1/2 plus x to the 7th minus 2.
And here, like this.
Yes, it was, and then it just find the derivative.
Very good. So we are asked to find the dy over dx, which is the same thing with f prime of x if you want to denote this by f of x. Good. So remember the power rule. The power rule states that we have to bring down the power and subtract 1 from the power. So we bring down the power and subtract 1 from the power. And we should multiply by x prime, but that is 1. For now. For now. Because you'll see what happens next. Okay. Perfect. So let's continue. And I'm on my page 2. So then f prime, or if you want to write dy over dx, they're both the same. When I bring down -3/2 and multiply by 7, and I get -21 over 2. Stop me if you have any questions at any point in time, right? And x, and maybe you want to do this on the side, -3/2 minus 1 is -5/2. So the power now is -5/2. Do we understand this step, everyone? Is that a yes?
Can you repeat that one more time?
Yes. So I have 7. I have to multiply by -3 over 2. So this is 7 over 1 times -3 over 2 will be -21 over 2. Is that okay?
Yep.
Then I have to subtract 1 from the power. That's the power rule. Negative 3 halves minus 1 is negative 5 halves. So this is the power negative 5 halves.
Okay, got it.
Now, thank you. Now I bring down negative 1 half. 4 times negative 1 half is negative 2. I copy x, and now I have to subtract from negative 1 half. I subtract 1, and the power is negative 3 halves. Finally, I got to x to the 7th, which is much easier because I have 7x to the 6th. I bring down 7 and subtract 1 from 7, which is 6. But when I differentiate negative 2 because it's a constant, I get 0. So again, what does this represent? So this is the rate of change of f of x, where f of x is continuous, no cusp, no corner, no vertical tangent, is differentiable. In other words. And to be exact, if I plug in a number for x, then I get the instantaneous. I get the instantaneous rate of change at any point where the function is differentiable. Is this okay now?
Yes.
Other questions? Was it something wrong, or did you?
Yeah, like I got to that part, but then like when you put the answer in, I think they simplify it even more than that.
They have to accept this answer unless they said that you have to change x to negative 5 halves into a radical or something like that.
Yeah, it just said find the derivative, but it had like square roots involved in it, like when I would put in an answer.
But it has to accept it as is as well. Did you try it like this and it did not?
No, I didn't try like that. So I'll try that next time I do it, though.
Yeah, but we can further simplify it. We can. So negative 21 over 2. Remember, the negative power is 1 over. It doesn't mean that the number is negative. It's 1 over. And this is x to 5 halves. And then minus 2, the same thing, x to 3 halves. And then plus 7x to the 6th. And now we have to remember, as we discussed a long time ago about this exponential rules. So remember, x to 5 halves, we said this is a radical. What is the index and what is the power?
The index is 5 and the
Careful.
power is 2.
The denominator is always the index. Always the denominator is the index.
So then it's 2 and then x.
So it's the square root x to the 5th. And now we can simplify this by rewriting it x to the 4th times x. And then the square root of x to the 4th is x squared. 4 over 2. 4 over 2, because we know there is a 2 in here. This one. So x squared is the square root of x. So this changes into this. And this will change into x, the square root of x. But I don't think that they are requiring all these steps. But it's possible. They should accept this answer. So I would like you to try it. I'll give it a point even if you make an error. It's okay. No worries. So then I have negative 21 over 2 times 1 over x squared, the square root of x, and minus 2 over x, the square root of x, and plus 7x to the 6th. And from here I can continue. I can even find the least common denominator, which is 2x squared, the square root of x, and so on and so forth. But I think that this is good enough for what we're trying to do here. Good, very good question. Did you encounter anyone? Did you encounter anything else? Do you have any other questions for me? Well, in that case, we're trying to make headway, and we're moving on to 1.6, which is the product rule. and the ratio or quotient better. Ratio or quotient rule. Okay. In 1.7, we're going to talk about something called the chain rule. That's it. No more rules of differentiation. This is it. Product rule, quotient rule, and then in 1.7, the chain rule. So let's start with the product rule. So notice that we only had, and this was a very good introduction. Thank you for asking that question. We only looked at functions like, let me just make up a very simple one. Let's say x to the fourth plus 3x to the third. Can anyone help us find the derivative for this one?
X to the third, 9x to the 9x squared.
That's it. I hope everyone understands. Who was that? Thank you.
Sam.
Sam, thank you. So 4, we subtract 1 from the power. 3 times 3 is 9. We subtract 1 from the power. This is the same thing with this weird case, right? This was more difficult. We had to work with fractions, subtract, and so on and so forth. But this is exactly the same rule. So notice that here we know how to differentiate if this is a difference. So we know how to differentiate powers. We know how to differentiate sum of terms or even difference of terms, same thing. Now we want to talk about the product rule. What if I have a product of two functions? What do I do then? So here it is. Here is the rule. We have to remember it or have it on paper at all times. Allow me to push my computer a little bit further. Okay, got it. Okay, so here's the rule. Function 1 times function 2. Any two functions. We're going to have plenty of examples in a minute. Prime. So in case we have a function that is a product of two functions, and we still want to determine its rate of change, which is a function, right? We still want to determine its rate of change, but it's a product. How do I find the derivative of a product? Okay, so here it is. First function prime multiplied by the second one not prime plus the first function and now multiply by the second one prime. Yes, you can twist these the way you like. It doesn't matter as long as you have both terms in there. I like to keep them 1, 2, 1, 2, 1, 2. But not everyone likes that method. It's up to you. So it's easier for me to remember, not to forget, right? To remember that 1, 2, 1, 2, 1, 2. In the first product, the first function is differentiated, and the second product, the second function is differentiated. So let's see how this works. I'm going to make one example up, and then you're going to pick or make up your own example. So here's an example. Let's say 3x squared plus 4 multiplied by 4x to the third minus 3x. Is this, and of course we want to differentiate this. And you could say, just distribute. You don't need to use this. Right. Yes, in this case, I can distribute. There's no big deal. But what if I have this? This to power 4 and this to power 10. It will take me 3 days. I'm exaggerating. Okay, 5 hours, 3 hours to take this to the 4th power and this to the 10th power and then multiply them. It will take me forever. So I don't want to do that. I will differentiate the product. We're not ready for something like this yet. So don't change the problem because we are not there ready yet. So maybe by the end of the class today, we'll be ready for that. So here's the rule. So this is function 1 because this is where the product is, and this is function 2. The product is here. This is function 1, and this is function 2. Good. So the first product here is the sum of two products. The first product requires us to differentiate the first function. Can anyone quickly differentiate this function for us?
6x.
That's it. Now I have to multiply. Thank you very much. Multiply by 4x to the third minus 3x. So this piece is done. I reached plus. I will copy the first function. Here's the first function. And now I need anybody to differentiate this function for us.
(12x squared).
Excellent.
I thought that was it.
I have to
-3.
minus 3 indeed. So the derivative of negative 3x, x prime is 1, so we have negative 3 in front. Yes, I can continue distributing, so I'll do it quickly. Everyone knows this algebra. Let me just finish it up. So 6x times 4, right? So 24x to the 4th. Then I distribute here, 18x squared. Then I multiply these two. So 36x to the 4th. Then I multiply these two, 48x squared. Then I multiply these two, negative 9x squared, and minus 12. Always present the polynomial in descending order. Obviously, degree is 4. That's the highest. 24 plus 36. And then the next in line is this term, right? So we have here 30, 30 minus 9, positive 21. And then finally minus 12. What is this? So this is the product of the original functions prime. Okay, I also would like to introduce the ratio or the quotient rule. And then we'll pick problems, you'll pick problems that you like. So now the quotient is first function over the second function, prime. This will be our quotient rule. This is will continue to be a quotient. The denominator is only squared, not differentiated. The numerator is the same with the product rule, but minus here. That's the only difference in the numerator. So 1 prime times 2 minus 1 times 2 prime. Okay, so let's